Welcome to this eLearn Security video training lesson on Android device interaction. In this video we are going to see how to interact with Android virtual devices and physical devices. We will see how to browse the device content, download and upload files to and from the devices, obtain an Android debug bridge shell, and install applications. The techniques that we are going to see are very useful during our test since they allow us to get complete access and control of the remote devices. The first thing we have to verify is which devices can we interact with. To get a list of these devices, we will use the tool called Android Debug Bridge. ADB is a command line tool that is available in the Android SDK. If we open the SDK folder and then browse Platform Tools, we can see the binary stored in this folder. ADB is composed of a client, a server, and a daemon. The client and the server run on our local box, while a daemon runs on the actual Android device. If the server is not running, we can start it by issuing the command adb start-server. As you can see from the output, now all the daemons on the devices are running. What does this mean? It means that we are now able to communicate with the devices through our ADB client. Before running any specific command, let's run ADB without any options to get the help menu. Here we have the help content. The first section of commands are useful to detect and set the target of our connections. For example, we can tell the ADB to connect only to a device that is connected through the USB. With the option -E, we tell ADB to use the running emulator as the target. -S is used to specify one of the available devices as the target. The devices option is used to list all the devices available. Since the daemon running on the device also works through TCP, we can start a connection by specifying the address and the port of the device. So all the commands in the first category are useful to specify the target device. If we scroll down, we can see another section called Device Commands. Here we have commands that allow us to move data to and from the device, get a shell on the device, print the log data on the screen, and forward socket connections from a local port to a remote port on the device. As we can see if we scroll down, there are many other options. Let's start seeing how to use some of them. The first command we want to run was listed in the first category and is the devices command. With this command, we list all the connected devices. As we can see in the Windows Start bar, right now we have 2 emulated devices running on this machine. In addition, we have a physical device attached through the USB cable. So if the daemon is running on every device, the command should print 3 devices. As we can see, we have 3 entries. The first 2 are related to the virtual devices running on the machine, while the last one is the physical device. Since there is more than one device, if we want to run a command, we need to set the target. To do this, we can use the option -S followed by the serial number or qualifier of the device and then the command to run. For example, let's see how to start an interactive shell on the first device listed. So the command will be adb -S followed by the device identifier, which is emulator-5554, and the command we want to run, which in our case is shell. Once we hit return, the prompt changes. This happens because we are now interacting with a shell on the device itself. From this shell, we can run some basic commands on the device. Let's see the current path with pwd command. As we can see, we are in the root folder of the device. Let's list all the files in here with the ls-l. Here we can see all the files and folders on the device root folder. And of course, we can navigate in the folders with the cd commands. Let's navigate to the SD card folder with the command cd space SD card and list all of the files. Note that this shell is not like other shells that we are used to interacting with. Some commands are not available or are slightly different. For example, if we try to run the ifconfig, we can see it returns nothing. This is because we have to explicitly specify the interface. So let's first list all of the interfaces available with the command ls/sys/class/net. Then we'll run ifconfig followed by one of the interfaces listed above. Let's use eth0. Now we can see it's working. While some commands are slightly different to use or have limited options, some others don't work at all. If we try to run uname, we can see that it returns command not found. So even if we have a shell on the device, we should be aware that we have some limitations in terms of commands that we can run. To cope with this problem, we can install on the device some third-party applications such as BusyBox, which provides standard Unix utilities. For this lesson, we will continue to use the ADB shell. As we have said before, from this shell we can navigate through files and folders, but we can also read the contents of files. Let's move in the folder where all the application data resides and see what information we can get. As we can see, we have a lot of application folders listed here. Let's select one and see which files are stored in it. Let's choose Evernote. In this folder, we will find all the files related to the application. So we will find all the data the application stores, such as accounts, configurations, and so on. Usually the applications store data in different ways. Some information is stored in XML files, while other data may be stored in SQLite database. Here, for example, if we go in the folder shared_prefs, we can see some XML files. In order to inspect these files, we can use the cat command. Let's print the content of this XML. As we can see here, we have some information about the configuration of the application, but we also have some information about the account used by the app. Here we can see the username. The Evernote email, as well as the email used by the user to sign in. If we take a closer look at the file, the entry last DB file path displays a path to an external file stored in the SD card. The extension of the file is .db, so we can't use the command cat to inspect this file, so we'll have to use the SQLite command, which is installed by default on the device. Let's open the folder path and list all the files in it. Since the file has a dot before its name, it means that it is a hidden file, so we have to add the option -a to the ls command. Here we can see all the files and folders. Before continuing, let's copy the path in Notepad since we are going to use it later on. Now we can turn our focus to the .db file. To inspect its contents, we have to load it with the SQLite command line tool. Let's run the command SQLite3 followed by the name of the file. We can see it works, and we can now run queries against the database. Now let's get all the tables with the command .table. As we can see, there are many tables, but let's focus our queries on the table notes. Since we are using the SQLite command line, we have to run a query to get the content of a table. Before running the select query, let's run the command .mode line, which tells SQLite to print each column in a row on a line. This will give us a better readable output. Now we can run our query statement, which will be select asterisk from notes semicolon. As we can see, we are able to read each column name and its value. This is information for each note stored. We can see who created the note, its title, and much more. So thanks to SQLite and ADB shell, we can also read the content of each database stored on the device. As you've probably noticed, in the database there is no sign of the actual content of the note. If we scroll up when we issued the ls command, we can see that we have a folder named Notes. The content of each note is stored in this folder. Let's close the SQLite command line with the .exit command and check this folder. Here we can see that we have a few folders with odd names. These names are composed with the first 3 characters of the GUID value. Here we can see that the GUID of the last note starts with D87, and here we have a folder with the same name. Let's enter the folder and run ls. Here we can see another folder. This time the name of this folder is the exact value stored in the GUID column. So let's enter this folder and run ls once again. Here we can see a file named content.enml. Let's run cat against this file and see what's in here. Now we have the full HTML content of the note. As we've seen with the ADB shell, we are able to navigate device folders and access the content of the file stored in it. Also from this shell, we can run some Unix commands as well as run tools such as SQLite. So now that we know how ADB shell works and what we can do with it, let's try to use some other commands. Let's exit the shell and run ADB to list all of the available options once again. In the device command, we can see that we can use 2 commands to download or upload files and folders to and from the device. Since we have seen how the Evernote app stores its notes, let's see how we can download its folders in order to edit a note and then upload it back onto the device. In order to download the Evernote Notes folder, let's write the command adb-s emulator-5554 pull, followed by the path of the file or the folder that we want to copy from the device. In our case, it is the path that we copied in Notepad before. So let's copy and paste it in the shell. Then we have to insert the path on our local machine where these files will be stored. So let's insert the path to our desktop. C users ELS desktop notes. As soon as we hit enter, we can see the ADB starts copying all the files onto our machine. In our desktop, we can see a new folder which contains all of the files of the Evernotes folder. Here we can see the folder Notes. So let's open the note and edit its content. Let's change the note with a new message. Let's change it to edited note. Now let's save the note and upload it back into the device with the command push. This command works in the same way as pull. The only difference is that this time the first parameter is the path of the file stored on our local machine, while the second parameter is the path where the file has to be stored on the device. Let's now open the Evernote application from the device and see if the note has changed. As we can see, the edits did take effect. In review, by using the commands pull and push, we can copy files to and from the device. This may be very useful during our security tests since we can change application configurations. Another useful option that ADB offers is the ability to install or uninstall applications on devices. To do this, we need the APK file of the application itself. For our purposes, we are going to use a custom application that we created. The command to run is very simple. As usual, we have to specify the target device and add the command install, followed by the path to the file stored on our machine, which in our case is C users ELS desktop simpleapp.apk. Once the operation ends, we can see the application has been installed on the device. There is the icon of the app, and if we start it, we can see that it works fine. Now that we know how to install applications on the device, let's see how to uninstall them. The command is very similar to the previous one, but this time we have to use the command uninstall followed by the package name of the application. To get this name, let's start the ADB shell and browse the folder /data/data. As we can see, here are all the package names of the installed applications. For example, we can see the folder where Simple App has been installed. So if we want to uninstall it, we have to use this name. So let's close the shell and run the command adb-s emulator-5554 uninstall, followed by the package name of the app, which is com.example.simpleactivity. The command returns success, which means that the application has been uninstalled. If we go back into the device, we can see that the application doesn't appear anymore in the launcher. Note that all the commands seen up to this point work for actual devices as well. As we have seen previously at the beginning of the video, we have two virtual devices and a physical device attached. So here we can see that the physical device has a different identifier. So let's try to get the ADB shell on it. Since it is the only device attached through USB, instead of using the -S option, we can use the -D, which instructs ADB to use as a target the only connected USB device. As we can see, the shell this time is slightly different. If we run the ID command, we can see that we are not root on the device. It means that we cannot access all the information on this device. If we navigate the folder data/data and try to list the contents, we get a permission denied message. This happens because each application runs in its own sandbox and with a different UID. In order to get root privileges, we need to run the command su. Note that depending on the configuration set on the device, we may need to confirm and grant root permission to ADB. Let's now run the ID command again, and as we can see, we are now root. If we try to run ls, we can see all the application packages are listed. On this device, we've already installed BusyBox, so we can use more of the standard Unix commands. For example, if we try to run uname -a, we can see that the command succeeded and prints the information of the device. On this device, we have also installed two applications that help us to interact remotely with it. The first is SSH, and the second is VNC. The two servers are already running on the device. If we run the command netstat, we can see that port 22 and port 5900 are in listening mode. Port 22 is the SSH server, while 5900 is the VNC server. An SSH shell is very similar to the ADB shell, but is slightly better. Since SSH is already running, let's see how to establish a connection. The first thing we need is an SSH client. In our case, we are going to use PuTTY, which can be freely downloaded at the following page. We have already downloaded it and stored it on our desktop, so let's run it and establish the connection. Here we need to set the IP address of the device. Since it is attached to the same network as the host machine, we can use the LAN address. If we go back in the ADB shell, we can see that the address is 192.168.3.23. So let's insert this address in PuTTY and click Connect. A new window appears and we are asked to insert the username to log in. Let's use root as username and then insert the password set on the device SSH application. As we can see, we now have SSH shell on the device. From here, we can run any command and tool we want directly on the device. We can see we are running as root because we are able to list and navigate files and folders as usual. The other service that is running on this device is a VNC server. VNC is a graphical desktop sharing system. This means that if we establish a VNC connection to the device VNC server, we will be able to view the device screen remotely. In order to use VNC, we need a client. In our case, we are going to use VNC Viewer, which is free and available to all platforms. Since VNC transfers a large amount of data, establishing a connection through Wi-Fi may result in a slow connection. To avoid slow connection speeds, we can use the cable connection, but we need to forward the communication using the ADB forward command. In our prompt, let's run the following command: adb-d forward TCP:5003 space TCP:5900. With this command, we are telling ADB to target the USB device and to forward the local port 5003 on our local machine to the device port 5900. So now that the forwarding has been set, we can run the VNC Viewer client and establish the connection. Of course, since we have set the forwarding, we will need to connect to the loopback address at port 5003. As we can see, the connection works, and now we are prompted to insert the password set on the VNC server app installed on the device. Once we insert it, we can see the device screen and we can interact with it using our mouse and keyboard. So as we have seen in this video, we can interact with devices in very different ways. We can use ADB to navigate and read files and folders on the device, as well as download or upload files from the device to our machine and vice versa. We have also seen how to use protocols such as SSH and VNC to get a shell on the device or interact with it directly from our machine. We advise that you test these techniques and the commands offered by ADB, since they will be used later on during the course. Thank you for joining us.